Last time we started section 2.3, and we had talked about several relationships, and let me just run through them real quickly to remind you where we are, because we're going to use those relationships today. We talked about intersection, and an intersection of two sets is the things they have in common. We talked about the union, which means including everything and everyone that's in both of those things or in either one of them individually. And we talked about the relative difference, and the relative difference is the idea of taking part of a set and excluding some portion of it, removing that portion of it. We also talked about the Cartesian product, but we're not going to see the Cartesian product coming up today. So what we are going to see is we're going to see how we're going to approach Venn diagrams. So the first thing I'm going to do is I'm going to show you a general form for a Venn diagram. Now, on a few of your problems in the book, they give you a different form for a Venn diagram to start with. That's okay. You can still do the same thing I'm going to do with the process. All right? They're just making the problem in all reality easier than the problem that is more general, which is the one we're going to do. So we're going to draw a rectangle. And because there's a set ABC, we're going to draw 3 circles in the rectangle. The 3 circles are going to overlap. That's the most general way you can draw them. Some of the ones that you're going to do in your homework won't overlap. That's okay too. And we need to label them. And just so that we're all labeling the same way, I label top left A, top right B, and the bottom one C. If you label them differently, it's not going to hurt anything in the end. But that's how I'm going to label mine. Okay? All right. There are several ways to do this kind of a problem. Some of them are more intuitive, like you look at it and you go, oh yeah, this would have to be this because I can reason my way through it. And that's okay. There's nothing wrong with it. I'm going to go with a method that's a little bit more concrete because some of us can't reason very intuitively when we're looking at pictures. I love visual diagrams, but sometimes I have difficulty with spatial reasoning. This is the reason I tell my husband on times that I can't load the dishwasher very well. He can fit more into it than I can. I don't know how he does it. He moves things around and all of a sudden he can fit in those 2 extra cups. And I don't get it. All right, so this kind of reasoning helps because it's a little bit more concrete. So here's what we're going to do. We're going to put numbers in every region on our picture. We're just going to label them with numbers. The numbers aren't really meaning that there's 5 things in them. That's not what they're going to mean right now. It's just a label. Okay, so we could use letters as easily as numbers, but I use numbers. So I'm going to do 1, 2, 3 straight across the top. I'm going to do 4, 5, 6 straight across the middle, 7 at the bottom, and then 8 on the outside. So if they give you a picture and you don't need 8 numbers, that's fine. Just put the numbers so that there's a number in every specific region. Okay? And then what we're going to do is we're going to work through this notation. But just like with algebra, we have order of operations that says that whatever happens inside of parentheses is what we do first. So the first thing we're going to do is we're going to look at A intersect B. And this is what I'm going to expect to see when I look at your homework, when I look at quizzes, is that you're going to write down A intersect B. And I skipped a step, I'm sorry. Let's move that down just a little bit. The 2 sets individually are A and B. All right, what items, what numbers are inside of set A? We're just going to list all of them. What do we have? 1, 2, 4, and 5. What numbers are inside of set B? 2, 3, 4, 6. And this says that I'm supposed to be finding the intersection. What does intersection mean? The same in both of them, right? It has to be what they have in common. What do these have in common? 2 and 5. So the intersection is 2, 5. And if you look back at the diagram, does that make sense? Are the numbers 2 and the numbers 5 inside of A and B and nothing else is, right? Okay, fantastic. All right, so the next thing we're supposed to do is we're supposed to somehow include set C in this discussion. So let's list the things that are in set C. What is in set C? I skipped part A, didn't I? How did my slide go to part B? Okay, we'll go back to A and it'll be really easy in a minute. I'm sorry. I thought it was weird that I was jumping into a 3 example when I normally do. Okay. Well, you know. All right, what's in set C? 4, 5, 6, and 7. And the notation over here says that what am I going to be doing? What does that notation mean? Union. Okay, so this is now going to be A intersect B. It's all of it. Union with set C. So what does union mean? It means combine it all together, right? It's what happens when you get married. You get all their debt and they get all your money, or something like that. Okay, you get it all. So we get everything. We get 2. I'm going to list them in order. 4, 5, 6, and 7. You can really list them in any order you like, but this is what we get. 2, 4, 5, 6, and 7. This is the supporting work, but this did not answer the question. The question asked you to do what? To shade. So you come back over here and you use a pencil or a colored pencil or a marker or a crayon, whatever you have in your bag, and you shade in region 2, region 4, region 5, region 6, and region 7. And this is your actual answer to the question. But if you give me the actual answer with no work to support it, you don't get any credit. It's just the way it's going to be, okay? I need to see your work to support it. All right, let's go back to the easier one. My apologies. Let's do this. All right, this one only has 2 sets that it's talking about. So when we draw a rectangle, we will only draw 2 circles inside. And those 2 circles will overlap. That's the most general way to draw it. It's universal set of U on the outside. We'll call this one set A and this one set B. Everybody good? We're doing the same thing we just did on the other one. We're going to label all the regions. We just don't have as many regions to label. So again, I start inside of circle A, 1, 2, 3, and then I put a number 4 on the outside. If you put your numbers in different places, that is totally fine. I will support whatever it is you've done, and we'll look for your values, okay? But this is the way that I will be doing mine. So going back over here then, this says that I have A with the bar on top. What in the world does that bar on top mean? Not in A. So what are the items, the numbers, the labels that are not in A? 3 and 4. 2 is in the overlap, so we don't want to include that one. This also says that I've got B complement that I'm supposed to be doing. So what are the items that are in B complement? 1 and 4, right? B complement means not in B. And then using these 2 sets, A complement and B complement, I'm supposed to find their what? Union. And union means you get everything. So what are my list of numbers that I should list for the union? 1, 3, and 4. And then over my diagram, what am I going to do? Shade 1, shade 3, and shade this big outer region called 4. I've got another one, but before I go on, any questions on either part A or part B done in the backwards order? Okay, let's give another one a try. C. 3 sets, so I'm going to create 3 circles inside of my Venn diagram. And we're going to label them just like the problem does, which is another A, B, C. And there's my universal set U on the outside. I'm going to go across the front, the top, 1, 2, 3, through the middle, 4, 5, 6. C, outer part of C is 7, and then an 8 on the outside. Labels. Somebody tell me the first set I'm going to write information down about. A, because it's inside the parentheses and it's listed first. So what labels, numbers, are inside of set A? Good. 1, 2, 4, and 5. What's the next set I'm going to write down? The complement of B. So B with that line on top. And this means everything that's not in B. So what numbers are not in B? 1, 4, 7, and 8. Very nice. And then how am I going to join these two together? An intersection. And what is an intersection? Where they overlap. So looking at these list of numbers, where do they overlap? 1 and 4. Okay. And then I'm supposed to use this, and I'm going to throw in a third set. What's my third set? The complement of C, or C complement. So what numbers are in C complement? 1, 2, 3, and 8. Remember, that means everything not in C. How am I supposed to, I'll mark this sort of like this. How am I supposed to join up these two sets that are between those horizontal bars? Intersection. And what does intersection mean? What they have in common, or where they overlap, right? So where do these numbers overlap? 1. If I come back to my diagram, I don't have to shade very much. Okay, is everybody all right with this idea? And there's nothing special about having the 3 overlapping circles in this pattern. So some of them that you're going to be given diagrams for, they won't necessarily overlap. That's fine. Just put numbers in where you do have different regions, and you can go from there. It's most complicated when they all 3 overlap. So the ones that you see in your book are going to be less complicated in a couple places.
Will we ever have more than 3?
We will not do more than 3. 3 will be it. Yes, otherwise we start looking like we're in the Olympics, right? Yeah. Yes, ma'am.
Back on A, on part A.
Uh-huh.
We used all the numbers. Is that because it's a union, so everything gets put in?
Correct.
And so it's not just whatever matches up?
Exactly. Intersection means what they have in common. Union means I get it all.
Okay.
So keep remembering the union is the idea of marriage, right? When you get married, you get it all. All right? It's a combination of everything at that point. All right. We're going to do one other thing with Venn diagrams. The numbers that we're going to see coming into play on these last 3 examples are actually numbers that mean cardinal number. It's the number of items inside of the set. It's not a label any longer. Okay? That's why you see N of A written down and not just A. So like when I was writing these things over here, I wrote A equals and I used my numbers as labels, right? These numbers I'm about to use are not labels. They're actually the number of items inside of a category. All right, so this is the most complicated one just because it lists it all kind of funny. And then what we're going to do is we're going to actually see how to start with something in context and how to use the information from this problem, how to do this problem. All right, so what you should notice on this problem is that it's talking about 3 sets, A, B, and C, right? And the most complicated way we can draw our diagram, as we've talked about before, is having 3 overlapping circles, so that's where we're going to begin. So we're going to draw that Venn diagram with 3 overlapping circles inside of a rectangle. We're going to give the circles the same names in the problem, A, B, and C, and the universal set U. So far, so good? Okay, now I want to show you that the order in which you're given the information may or may not be a helpful order for putting information into your diagram. So, if you were to start with the very first piece that says N of A equals 24, that means that everything inside of circle A has to be total of 24. The problem with that is that there's 4 regions inside of circle A. And if you decide to go with trial and error and dividing up 24 into 4 different places without knowing how much goes anywhere you want, it's probably going to take you a long time. In fact, you probably won't be able to finish the problem. There's just too many options, okay? So that first line of information telling you how many items are in set A and set B and set C individually is not helpful at all right now. Make sense to everyone? So let's look at the second line of information. The second line talks about the intersection of 2 sets. So this one says A intersect B. Well, here's circle A and here's circle B, and they intersect in this sort of a football shape right here, right? But I still have 2 places that are supposed to now add up to 10. Well, now that's way better than 4 places adding up to 24. But I still don't want to have to do trial and error with the number 10 and go 1 and 9 and 10 and 0 and 5 and 5 and 4 and 6. I don't want to do that. That would not be a good use of my time. So this middle row where we compare two sets at a time, also not very helpful at the moment. Okay? All right, last row has two pieces of information. The first piece of information is very helpful. This says that I'm intersecting all three sets at the same time. And where is that? That's right in the middle. That's where I'm going to start. So I know that there are 6 elements. I don't know what they are, because this problem doesn't even have any context. But there are 6 items in the very middle of this diagram. And once I do this, once I list it, I'm going to mark a line through it just so that I remember I've taken care of it now. I'm done with that. Now the last piece of information, n of u equals 50, is also unhelpful. It's actually the last piece that we're going to use because it means everything in the entire rectangle has to add up to 50. So that's the last place we're going to actually be in our problem. Okay, but now that we've put something in the very, very middle of our diagram, going up just one line is a very helpful place to go. It says n of a intersect b is 10. So this half, or this football shape in right here has to add up to 10. But 6 of them are already there. So how many are left here? 4. So I've got a 4 in that upper part of that region. And I can mark a line through that one. So we're going to continue along this, this line of text. This now says B intersects C is 8. Well, here's B, here's C, and they intersect right here. It's supposed to add up to 8. Well, there's already 6 in there, which means how many do I have left? 2. So I'll have 2 in the outer region of BC right there. And I'll mark off B intersects C. The next one is A intersects C. So here's circle A, here's circle C, intersecting right here in this football. It's supposed to be 15 of them, and there's 6 already there, so how many is left for out here? 9. Okay, everybody good so far? We already said the very last thing we're doing is the 50, so the next thing we must do is go back up to that first line of text. All right, so in the first line of text, it says that n of a is 24. Well, circle A originally had 4 areas in it, and I didn't know any of them. But now there's 4 areas, well, still 4 areas in it, and I know 3 of them, which means I should be able to find the 4th, right? 4 regions. So what's 9 plus 6? 15 plus 4? 19, and there's supposed to be 24, so how many am I left with? 5? All right, so this one's done. How about n of b? Also supposed to be 24. Over here in circle B, I've got 4, 6, and 2. That is 12, so how many do I have left? 12. 12 more to get my 24, right? Yeah, good. Last piece along that top row is n of c is 26. So I'm supposed to have 26 in this bottom circle. I have 9 plus 6 plus 2, which is how much? 17. How many is left if I'm getting up to 26? 9 more. So I need 9 down here. And I'm done with this piece. So I've done everything now except for n of u equals 50. So somebody needs to add up everything that's in my picture so far. Somebody already has, I can tell. Who's already added all those numbers up? What do you have, Jessica? 47, which means how many are we missing? 3. So we've got 3 out here. Okay, it's process of elimination. It's like doing a Sudoku puzzle or something like that. I mean, really. I mean, you're just working with what you can do for the first part until you can figure out the pieces that are remaining. All right, so we're going to see how this can be used in context. We've got 2 word problems. Joe Long works on albums for musicians. Last year, he worked on 12 projects. He wrote and produced 2. He wrote 5. He produced 7. And then we've got some questions that we're going to answer. But we're going to answer the questions after we create a Venn diagram. So, a Venn diagram. How many categories of things are going on in this problem? 2. What are those categories? Yeah, and we can label them that way. There's nothing wrong with putting language inside of our Venn diagram. These are ones he wrote, and these are ones he produced. And this is our universal set U. Now let's go back to the information that we are told. We are told he wrote and produced 2, he wrote 5, and he produced 7. What piece of that is the most helpful to start with? The one that's got both of them in there, wrote and produced. He wrote and produced 2. Where will the number 2 go? In the middle. All right, so I am finished with this piece of information. All right, let's go to the next one. It says wrote 5. He wrote 5. What number am I going to put in the outside of the wrote circle? 3. Why not 5? I already have 2 in the middle there that already count as 2 of them that he wrote. So we just need to make sure that whole circle equals 5, and now it will. All right, so this one's done. Next one. He produced 7. Oh, so I need 5 in the outside circle for the exact same reason, right? This circle for produced needs to add up to 7. 5 will make it happen. How many are currently represented in my diagram? 10. But what does it say over here about these projects? There were 12. So he must have done something else on the other 2 projects. We don't know what that is, but it was something else. Maybe he sang in them. I don't know, or something. He did something. Now, using this diagram, we can answer the questions that we were asked. How many did he write but not produce? 3. How many did he produce and not write? 5. And how many did he neither write nor produce? 2. The questions are easy to answer once you have the picture finished. I always like this one. Okay. A youth group was asked the questions regarding songs they'd learned as children. Upon surveying the 34 youth, the following informations were obtained. 15 had learned Jesus Loves Me. 19 had learned the Bible. 28 had learned This Little Light of Mine. 13 had learned Jesus Loves Me and This Little Light of Mine. 15 Jesus Loves Me and the Bible, the Bible. 14 the Bible and This Little Light of Mine, and 13 had learned all 3. And then we want to know several questions about these children. We need a diagram, and how many circles are going to be in my diagram? 3. And the circles are going to be labeled the names of these songs, right? Sometimes I have people not put the rectangle around it. We need the rectangle around it because there's sometimes information in the outer part of that rectangle. So make sure you're using that universal set U. All right, so I'm going to list them in order. So this is Jesus Loves Me. I'm just going to call it Jesus. The next one was the Bible, so I'm going to put Bible over here. And then the last one was This Little Light of Mine, so I'm just going to write light on the bottom circle. All right, looking at this list of information, which piece of it is most helpful with which to start? The last one. The 13 had learned all 3. So I'm going to mark off that we're going to take care of that. What will I put and where? 13 in the middle. Very good. What is the next piece of information you guys want to do? Second from the bottom. If we just maybe work from the bottom up, that might work. So let's give it a try. It says 14 had learned the Bible and This Little Light of Mine. Well, the Bible is my top right corner. The light of mine is the bottom one, and there's 13 in the middle contained in both of them already, which means what needs to go out here? Just one. One additional child or youth. And we've done that one. 15 had learned Jesus Loves Me and the Bible. Jesus Loves Me is on the top left. The Bible is on the top right. So the overlapping region in the middle here already includes the 13. How many more people do I need? You got it, 2. And we're done with this one. 13 had learned Jesus Loves Me and This Little Light of Mine. What does that tell you about this little region right here? It's actually 0. So it's okay that there's a 0 on your diagram. What it really means is that we could have drawn the picture slightly differently, but we had no way of knowing that starting out. So we're just going to put a 0 on it. Now, you can't put negatives in your diagram, though. Okay? No negative numbers, because these are supposed to be actual numbers of people or categories or whatever, whatever's going on. It's an actual number of things that you can count, and you can't count a negative number of items.
Does that mean we can't have decimals either?
Correct. Yes. When we're labeling these with values, these are cardinal numbers, the number of items in something. All right, moving on along. We have 28 that had learned this little light of mine. Oh my goodness, that's my bottom circle. I'm supposed to have 28 in this bottom circle. I have 13 and I have 1. How many more do I need? 14 more. So there's 14 down here. I am supposed to have 19 included in the BIBLE circle. So that's the top right. I have 13 plus 2 plus 1, which is a total of 16, which means I'm missing 3. So that one's done. And then I have 15 had learned Jesus loves me. So 15 in the top left circle. Did I say that right? Was it 15? Yeah, 15 in the top left circle. And I've got 13 and 2 and 0 there, so that's another 0. Alrighty. I believe we have one more part that we haven't done. Right up here. We know there's 34 kids that they talk to, right? How many people are in my diagram so far? How many? 33. So how many go on the outside? 1. There's 30, unless we added it wrong, there's 33 and there's 34 total. So I think there's just 1 on the outside. All right, so we're going to answer these questions. How many children had learned exactly 1 song? So where would the exactly 1 places be? Right, the 14 and the 3. And it would be very helpful and advantageous to you if you wrote that down. 13 plus 3. I know you know how to add 13 plus 3 without writing it. Did I write one?
14.
I'm sorry, 14. Thank you. I know you can add those without writing it, but that tells me where in your picture it came from. So if you make a mistake, I can actually give partial credit or something, right? 14 plus 3 would be 17. How about at least 2 songs? So that's different. This says exactly, this says at least. What does at least mean? 2 or more, which means I get the 3 category in the middle too, right? So the 2 or more gives me the 2, the 13, and the 1. So I have 2 plus 13 plus 1 for a total of 16. And how many had none of these songs? That one's 1. How about this little light of mine only? Is that 14? Yes. Oops, sorry about that. That one was 14 here. The outer part of the light of mine circle. Okay, one last question. Cartesian product. We mentioned this last time. Cartesian product takes elements from 2 sets and it puts them in ordered pairs. Okay, so you have a set with people in it from my family, you have a set of people in it from my sister's family, and we pair people up in some fashion. Okay, we set up pairs. Cartesian product. Is the Cartesian product always commutative? Why or why not? So when we did this last time, we created set A and set, oops, hang on, let me get back there. There it was. Set A and set B. And we listed A cross B, and these are the items we got. X1, X2, Y1, Y2, and so forth. If I switched it and I did B cross A, what would change? But what would the items be? How would the items be different? Right, so instead of having X1, I would have 1X, right? Are you guys with me? Okay, so in general, the problem with that is that you know a Cartesian product example that you've seen used quite a bit. It's the ordered plane, right? X's and Y's. So think about what happens when you have the XY ordered plane. Here, right here, would be the point 1, 3. What would happen if you switched the order? You would be at 3, 1 like this, right? Are those the same location? No. All right? See, the Cartesian product's ordering matters in some cases. If we just paired up myself and my sister's kids, like if we just did that kind of a pairing, it wouldn't necessarily matter. But it does matter in some cases. So in general, it matters. Oops. So we're going to write down that no, it's not commutative. Because in general, 1, 3, for example, would not equal 3, 1. X1 would not equal 1x. The order would be a different ordering. We would be in a different location. And we'll stop there.